Today we are going to talk about translating parabolas. Last lesson we already discussed how to graph them, so now we are going to be translating them and moving them on the graph. So for the orientation of parabolas, when a is negative, the graph of ax squared plus bx plus c is a parabola that opens down. So think of negative down like a frown. When a is positive, the graph of ax squared plus bx plus c is a parabola that opens up like a cup. For the two orientations above, which one has a vertex that is a maximum? And which one has a vertex that is a minimum? So when we think of a parabola that is negative, has a negative a, it's going to face down like a frown. So this would be considered a maximum. When a is positive, it's going to open up like a cup, and this is going to be a minimum vertex. The formula for the line of symmetry, as we have discussed before, is negative b all over 2a. Using the function y equals negative 3x squared plus 2x plus 1, we're going to tell whether the graph opens up or down. When we see this negative a, which is negative 3, we know that it's going to open down. When we know that the parabola opens down, it's going to look like a frown, and we consider the vertex to be a maximum. Now, in order to find the equation of the line of symmetry, we will use our equation negative b all over 2a. Our b is positive 2, so we're going to say negative 2 all over 2 times our a, which is negative 3. Now we will just simplify it and get negative 2 over negative 6. We always know that a negative over a negative turns into a positive, and then 2 over 6 reduces to 1/3. So our line of symmetry is 1/3. Now we will find the coordinates of the vertex. We already have our x from the line of symmetry. So what we will use is our original equation and plug in the x to find our y. Now we will just simplify. So negative 3 times 1/3 squared, which is the same thing as 1/9, plus 2 times 1/3, which is 2/3, plus 1. Continue to simplify. Negative 3 times negative 1/9 is negative 3 all over 9. And I'm going to reduce that and make it negative 1/3. Plus my 2/3 plus 1. Now we will combine all of those and we get negative 1/3 plus 2/3 is 1/3. 1 plus 1/3 is just 1 and 1/3. Or we can make it to be 4/3. So the coordinates of our vertex is our x, which we said is 1/3, and our y is 4/3. A reflection is a flip over a line. The line of a reflection is the line where the mirror or fold is. Think about the line of symmetry and how we reflect points over that line in order to graph more points on our parabola. The properties of a reflection are: the image is congruent to the original figure, the orientation of the image is reversed, the line of reflection is perpendicular to and cuts in half any segment connecting corresponding points on the image and the original figure. So let's look back at our Desmos activity. We first graphed the parabola y equals x squared. Then we graphed the parabola y equals x squared minus 4. That minus 4 showed us that it was the same parabola except it moved down 4 units. Then we had the quantity x plus 4 squared compared to our original y equals x squared. And what happened here is it moved to the left 4. So just like we've graphed other lines, when it's on the inside, you go the opposite direction of the sign. So it was an x plus 4, and we moved x over negative 4 units. Then we had the parabola y equals x minus 4 squared. So what happened is instead of, when we see the negative 4, it moved to the right 4, the opposite of what that sign is. So it moved a positive 4 to the right. Now we will go back to our notes and we will describe the translation of these graphs without using Desmos. So we are comparing it to the y equals x squared, just like our Desmos activity. So for part A, we have y equals x squared plus 2. When it's on the outside of this, instead of like the inside, like part C, this is on the outside. So we're going to move up and down. Think of when you're outside, you can only move up and down, because inside you can't do that because of the ceiling. So in the inside, you would move left and right. So for part A, we have x squared plus 2. So the translation is we are moving up 2 units. And then we have part B, and it's still that minus 2 is on the outside, so we are going to move down 2 units. Now for part C, we have the quantity x plus 2 squared. And when it's inside those parentheses, that means we're only moving left and right. And when it's a positive, think of the opposite, and we are going to move left 2 units. So then for part D, we have x minus 2. So we're going to do the opposite of negative, and we're going to move right 2 units. So the next question is, which of the graphs above have the y-axis as their line of symmetry? So in the back of your mind, you want to think of a graph. This is your y-axis. Which one will have that as the y-axis as my line of symmetry? For part C and D, we had to move left and right. So that would not allow the y-axis to be the line of symmetry. But for part A and B, we just moved up and down along that y-axis, so the graph A and B would have the y-axis as their line of symmetry. Our next question is, which of the graphs above have their vertex on the x-axis? So that means they're staying along that vertical line. So when we start from our original y equals x squared, we can only move left and right. That is where you see that part graph C and D both moved left and or right. So the graph C and D were the only ones that have their vertex on the x-axis. Now we would like to match each graph with its equation. Looking at part A and thinking of our original graph that we compare it to, that y equals x squared, what happens to x plus 3 inside? Where are we moving? We are moving left and right when we are inside the parentheses. So therefore, since it's plus 3, we want to think we're moving the opposite of that. So like negative 3, so we're moving left 3. Of these 4 options, which graph moved left 3? Graph D moved left 3 because it started from here at the origin and moved left 3 units. So part A is matched with graph D. For part B, we have the equation y equals x squared plus 3. And that plus 3 is on the outside of the parentheses, it's not with the x squared. So what's happening is it's moving either up or down. And since it's a plus 3, that means we are going to move up 3. So which graph, A, B, or C, is moving up 3 from the origin? Graph B is moving up 3 units from the origin. So part B goes with graph B. For part C, we have y equals the quantity x minus 3 squared. And as we've said before, when it's inside, it's going to move either left or right. And we notice that it says a negative 3, so we want to think of the opposite. So it's going to move right 3 units from the origin. So which of the graphs, 2 graphs we still have left, part either graph A or graph C is moving right 3 units? Graph A is moving 3 units right from the origin. So C goes with graph A. And last but not least, we have part D, which is y equals negative x squared. We do not have anything on the inside of the parentheses or on the farther out right side outside of the parentheses. So that means the parabola's vertex is going to be at the origin. But what it does have is this negative